Hi, my name's Mark Napoli and welcome to this video on container virtualization and how it's changing the way applications are deployed in the cloud. Now you might ask the question, why do we need container virtualization? What does it do for us? Well, I think the reason this technology came about is from two separate trends. The first would be from enterprises who want to ship their applications faster and more securely. They've been moving towards agile software practices to get that done, and containers are a big part of that trend. The other one would be from developers themselves, and developers are always looking for better ways to manage and build and deploy their applications, especially in the new world of cloud. So developers are always trying to avoid the "well, it worked on my machine" problem, which is a difficult one when you're looking at a scenario with multiple libraries, multiple dependencies, and a fairly complicated deployment process. Containers can simplify that. So we're going to be focusing on Docker for the rest of this video, and Docker is an open source project that helps automate the deployment of containers on a Linux system. So if you're familiar with Linux, you know that the Linux kernel has a number of features, one of which is the namespace feature, or the ability to create separate namespaces within the Linux kernel. Now, if you've ever logged on to a Linux machine, you'd see a directory structure, that would look like this. You'd have your root folder, you may have a user folder and a var folder, and then you may have a home folder as well. Now, you can use chroot as a command to make this folder your new root directory. And that directory now becomes a new namespace. And that concept can be extended to cover things like the process tree and the networking interfaces, and all of a sudden you've gone from having one environment to having the one Linux operating system acting as many different environments. Now, to understand how container virtualization is different to traditional hypervisor-based virtualization, we can compare the two. So if you look at the stack with hypervisor-based virtualization, you have your infrastructure at the base layer, you have a host operating system that sits on top of that, you have a hypervisor that runs on top of that, and typically the cloud provider you're using will take care of all of that in the stack. Sitting on top of that, you would have a number of guest OSs. So I'm going to draw them up here in green. You'd have guest OS 1 with its binaries and the application you're running in operating system 1, and the same for OS 2, which could be the same operating system and could even be the same set of binaries and libraries. So it becomes application 2. Now, you can see that if they are indeed the same operating system and the same binaries, there is going to be a lot of double up. The way it works in a container world is that the infrastructure is still the same. On top of the infrastructure is a plain OS, and running on that OS is a container service, typically Docker, which will work with Docker containers. Now, on top of the container service, you have your Docker container. So wouldn't it be nice if, as a developer, you could take all of the binaries for your code, the libraries, the dependencies, the configuration files, the folders, and package that up into something that you could ship around? Well, that's what a container effectively is. So on top of this, you would have container 1, which would have your binary, your libraries, and application 1. Now these containers are much more lightweight than an entire virtual machine for your application, and so you can run a lot more on the same infrastructure. And actually that starts to lend itself to a microservices architecture, which is effectively another way of saying take your big monolithic application, break it up into chunks, make them small and modular, and give them a way to talk to each other to achieve a common goal. So with that in mind, we should look at what a container actually is and what characteristics it has. So the first thing is that a container is immutable, which means it doesn't change over time. The second thing is that it is stateless, which means as it runs, it doesn't maintain a state that changes over time that you can then follow along and see what's changed within that container over time. Once the container starts, it's set, almost set in stone as it runs. And so you should really think of them not as a virtual machine that you can log in and out of and change around, but rather as an isolated environment for you to run your application. There's no persistent storage within the container. There is a way to mount external drives into the container, but again, this should be thought of as a hermetically sealed environment. If you want to have a use case for containers, there are many, but we'll look at one such as a 3-tier web application. So within that architecture, you would have 3 containers, one for the front end for your HTTP daemon, the second for the application, and the third for the database. Now with those containers set up and sealed, you would ship them into your cloud provider and then use the cloud provider's scheduling to arrange the way that those containers would run. So you're not, with a cloud provider, actually manipulating the infrastructure, but you are specifying the way that your containers would like to run, and that's something that the AWS EC2 container service would do for you, for example. Hopefully that gives you an understanding of container virtualization, how it's different from hypervisor-based virtualization, and some of the features of a container. Thanks for listening.